How are you, all of you? I hope you are fine. Have you seen the previous videos what I have uploaded in my YouTube channel as well as in the e-learning site? Please don't forget to view the previous videos. In today's class, we will see about these passive electrical components, that is especially resistors. In this subtopic, we'll see classification of resistors, types of resistors, that means a standard wire wound resistor, carbon film resistor, maximum power rating, and also temperature coefficient. Temperature coefficient. What is a resistor? What is a resistor? A resistor is a passive element in a circuit that provides a resistance to the flow of current. It will resist the flow of current in a circuit. That is what we call a resistor. And resistance is a measure of the opposition to the flow of current in a resistor. In a resistor. The opposition to the flow of current in a resistor. The larger a resistor's resistance, the greater the barrier against the flow of current in that path. What is the unit of resistance? It is ohm, and its symbol is represented like this, as you have seen in the screen. What is the symbol for resistors? The symbol, like a saw shape, a saw shape. This is a fixed resistor, and this one is a variable resistor. This one is a variable resistor. So this is the symbol of a resistor. What types of resistors do you know? What types of resistors do you know? In the broad classification, we will classify the resistors as fixed resistor and variable resistor. When we say fixed, the value is fixed, it is not variable. And when you say variable resistor, it has some points to connect either in series or to add resistors in series to add the value of that resistance. So broadly, we will classify resistors into two, that is fixed resistors and variable resistors. When you come to these fixed resistors, you have a carbon composite resistor, film resistor, wire wound resistor, and resistance wire resistor. In the variable category, you will have a rheostat, potentiometer is there, thermistor, humistor, varistor, and photoresistor. We will see this one by one. Resistors are produced with a wide variety of materials and manufacturing process. During the manufacturing process of resistors, the manufacturers will use different types of materials and different manufacturing process. Each resistor material has its typical properties and specific areas of use. Let's see. The first one is a wire wound resistor. A wire wound resistor. As the name indicates, the wire is wounded and it is made in the compact form to get some values of resistance. So made with coils of resistance wire often enclosed in a ceramic to help dissipate heat and protect the resistive wire. As you remember, a resistor will resist the flow of current and it also dissipate energy in the form of heat. So to dissipate that heat and during the dissipation process, this ceramic will help these resistors accurate and heat stable. These were one types. The resistance value is often marked, used in higher watt circuits, often 2 watt or higher. An ignition ballast resistor is an example of wire wound resistor. As you can see from this, in this image, the wire is wounded. The wire is wounded and it is enclosed in the ceramic. So these types of resistors are called wire wound resistors. The other type of resistors is carbon composition resistor. Carbon composition resistor. As the name indicates, the resistive element is made from a mixture of fine carbon particles and a non-conductive ceramic material. A non-conductive ceramic material. It is made from a mixture of fine carbon particles and non-conductive ceramic materials. The substance is pressed in a cylindrical shape and packed. The resistance value depends on the dimension of the body and the ratio between the carbon and the ceramic material. These carbon composition resistor types. More carbon means a lower resistance. More carbon means a lower resistance. Carbon composition resistors are remarkably reliable but have poor accuracy with a maximum tolerance around 5%. Their tolerance is around 5%. Around 5%. The other one is carbon composite resistor. have low inductance, ideal for high frequency applications, very cheap to make, have very large tolerance. The tolerance is very large here also in the carbon composite resistors. The other type is carbon film resistors. Carbon film resistors. They are constructed out of a ceramic carrier with a thin pure carbon film around it. The functions are resistive materials. The functions are resistive materials. Carbon film resistors are significant improvement on carbon composition. We have seen already carbon composition. What does it mean? The typical use for a carbon film resistor is in high voltage and temperature application. Their operating temperature are up to 350 degrees centigrade. This is too much. This is too much. The resistive value of the resistor is controlled by increasing the desired thickness of the deposited film by by desiring the thickness of the deposited film, we can control the resistive value of the resistors. We can get up to 10 mega ohm, and their tolerance is somewhat good, that is 1% or less. The other one is a variable type of resistor, that is a rheostat. This rheostat is adjustable resistor used in applications that require adjustment of current or varying of resistance in an electric circuit. If we want to reduce the current, we can increase the resistance by using this rheostat. As you can see here, we can manage the resistance by moving the tap point forward and backward. So while we are moving to here, we can increase the connection of the resistors connected in series to the initial point. So this is what we call a variable type of resistor and what we call a rheostat. The other type of variable resistor is a potentiometer. A potentiometer or a pot in electronics technology is a three-terminal device, a three-terminal resistor with a sliding contact that forms an adjustable voltage divider. Here you can see that they have three terminals. So the potentiometer are commonly used to control electrical devices such as volume controls, joysticks, etc. So this is a pot. So you can move this terminal, and by moving this terminal, you can adjust the resistance value. The other type of a variable resistor is a thermistor. What does mean thermistor? A thermistor is a type of resistor whose resistance varies significantly with temperature. It is a resistance significantly vary with temperature. As the temperature may increase by different factors in our circuit. So during that time, this thermistor may be incorporated in our model, and we can sense the change in temperature by this thermistor. A thermistor can be used as a current limiting device for a circuit protection as a replacement for fuses, because it will vary as the temperature increase. The resistance of this thermistor will also vary significantly. It will used in protection circuit. The other type of variable resistor is a photoresistor or a light-dependent resistor. What is a photoresistor? A photoresistor is or a light-dependent resistor is an electronic component that is sensitive to light. Temperature and light is different. Thermistor is related to temperature, but here when you come to this photoresistor, it is sensitive to light. When light falls upon it, the resistance changes. These light-dependent resistors are made from semiconductor materials to enable them to have their light-sensitive properties. How it works? This LDR or light-dependent resistors, how it works? Photoresistors work based on the principle of photoconductivity. What's photoconductivity? Photoconductivity is an optical phenomenon in which the material's conductivity is increased when light is absorbed by the material. When light is absorbed by the material, the conductivity of that material is increased. This phenomenon is known as photoconductivity. Photoconductivity. When light falls, that is when the photons fall on the device, the electrons in the valence band of the semiconductor material are excited to the conduction band. As you remember from the previous videos, in the subatomic particles, there are electrons which are revolving around the valence shell. So to conduct or to move electrons, at least this valence band electrons should jump to the conduction band. So here in this photo resistors, when light is falls, the photons fall on the device, the electrons in the valence band of the semiconductor material are excited to the conduction band. That means it increases its conductivity. These photons in the incident light should have energy greater than the band gap of the semiconductor materials to make the electrons jump from the valence band to the conduction band. What are the characteristics of these photoresistors? Characteristics. Photoresistors or light-dependent resistors are light-dependent device whose resistance is decreased. And you see, whose resistance is decreased when light falls on them, and that is increased in the dark. It will increase in the dark. If the resistance is decreased, the current will increase. The current will increase, or the conductivity of that material have been increased. When a light-dependent resistor is kept in dark, its resistance is very high. Its resistance is very high. This resistance is called dark resistance. We call it the resistance of these photoresistors which are located in the dark is a dark resistance. A dark resistance. How can we determine the resistance power rating? The resistance power rating. As we have already defined, the resistance will resist the flow of current in a circuit, the flow of current in the circuit. But how much power? How much power it will resist? How much power it will resist? That means as the current increases, is that always, or as the voltage applied in that circuit is increased, is that always functional? That resistor to oppose the flow of current is the main issue here in the determining the power rating of the resistors. The resistors. The power rating of resistors can be calculated using a formula, that is P, which is equal to V times I. P, which is equal to voltage times current, or we can substitute here. We can substitute what does mean V by itself means also, that is V means by substituting, by using Ohm's law, we can get this equation. This equation. V by itself is I times R. I times R. So it will be I square R. I square R. Or in other terms, we may also substitute what does mean I. I means V over R. So if we substitute I, we'll get this V square over R. V square over R. So by using this either of the two, these three formulas, we can determine the power rating of our resistors. As a designer, you will select some ohm values of your circuit, but how much current it will flow in that circuit is the main issue while you are determining the power rating of your resistors. The larger the power rating, the greater the physical size of the resistors. The physical size of resistors. When used in an AC circuit, the AC impedance of a resistor is equal to its DC resistance. You know what does mean AC and DC. When we say AC, it is alternating current. When you say DC, it is direct current. Direct current. So a circuit designer must pre-calculate the maximum expected power that may dissipate across the resistor. So you should calculate before applying a current or a source to your designed circuit. You should calculate the maximum expected power that may dissipate across your designed circuit. By pre-calculating this power, the designer can choose the right power rating for a resistor used in the circuit. You know your resistance by your design, So you can easily calculate the power. For the time being, let's say, for example, if you have as a design procedure, you have selected a 330 ohm, then what will be the maximum power? Possibly the maximum power if your circuit, the supply voltage is 12 volt. 12 volt. If it is 12 volt, you can easily calculate from by using the previous formula, that is you have a voltage and you have a resistor, so you can get the power rating or the power dissipation of the resistor across your resistor. So you can calculate like this one. So approximately the designer should select a 0.5 watt power rating of your resistor. If you have misselected the power rating of a resistor, it will malfunction. It will not properly work. So you should take care of the power rating of your resistor while you are buying from a different market. The other thing is temperature coefficient of a resistance. Temperature coefficient of a resistance. The resistance of different materials vary with temperature. So we should know about temperature coefficient of a resistance. The temperature coefficient of a resistance measure changes in electrical resistance of any substance per degree of temperature change. Per degree of temperature change. Let us take a conductor having a resistance of R naught at 0 degree centigrade and RT at T naught degree centigrade respectively. From the equation of resistance variation with temperature, we can get RT over R naught, which is equal to T naught plus T over, here it is. Yeah, as you can see here, from this equation, you can relate RT over R naught, which is equal to T naught plus T. T naught is the initial temperature. This one is the initial temperature, and T is at some temperature. After some temperature, you want to know the resistance of that material. This implies RT, which is equal to R naught plus R naught T over T naught. Or which is equal to R naught into 1 plus A naught T. So this is what we call a coefficient, temperature coefficient of a material. This is the temperature coefficient of a material. This alpha naught is called the temperature coefficient of a resistance of that substance at 0 degree centigrade. From the above equation, that is this one, from this equation, it is clear that the change in electrical resistance of any substance due to temperature may depends upon three factors: the value of the resistance at the initial temperature, the rise of temperature, and the temperature coefficient of resistance alpha. The temperature coefficient of the resistance alpha. So this alpha naught is 1 over T naught. T naught is the initial temperature, and this alpha naught is different for different materials. So temperature coefficients are different in different materials. For the time being, if we see this table, these are the temperature coefficient. The temperature coefficient of a silver. These are the temperature coefficient of copper. These are the temperature coefficient of copper. So different materials have different coefficient of temperature for their resistance. This is all about today's class. If you have any question, you can put on the comment box. Thank you for your attention.